Assalamu alaikum, students. And we are starting now our acceleration due to gravity. We will study in this chapter about the objects which fall freely, and then we will study about the objects which experience air resistance. First, free fall motion without air resistance, and then with air resistance. So, in today's topic, we are going to apply the formulas which we studied in the previous chapter to the objects which fall freely. Okay, in previous lecture, we analyzed one dimensional motion, that is horizontal motion. We studied about displacement, velocity, and acceleration, and we applied the formula for to the bodies which move at the constant acceleration, and we just discussed about the increasing and decreasing acceleration also, but that was all for the horizontal motion of the bodies. In this video we will study about the vertical motion, that is motion, free fall motion when there is no air resistance, and we will apply those formula to the objects which fall freely. Okay, and they fall with the constant acceleration. As we know that for the constant acceleration to be produced, an unbalanced force acts on the body. Okay, for horizontal motion also F is equal to ma is applied to the bodies on which an unbalanced force F is acting. So in the same way, when object is dropped from a height and it falls and it accelerates, it means some force acts on the object. So that force is actually gravity. If you were to drop two metal balls from the top of a high building using ball of very different masses, say one is 5 times heavier than the other, then what do you think would happen? A, the heavy ball would hit the ground significantly before the lighter ball, or the lighter ball would hit the ground significantly before the heavier ball. C, the two balls would hit the ground at almost exactly the same time. Okay, that all depends upon the air resistance. So here suppose we ignore the air resistance, so answer would be C. Both the balls, irrespective of their masses, will hit the ground at the same time. So here we have Galileo's idea. Galileo, he was a scientist, and before him it was believed that falling objects quickly reached a natural speed proportional to weight, then fell at that speed. So Galileo argued that in fact falling objects continue to pick up speed unless air resistance dominates, and that this acceleration is the same for all the objects. So before Galileo, scientists they used to think that the lighter objects they fall slowly and the heavier object they fall faster, but Galileo, his argument was what, that the objects they all acquire increase in the speed at the same rate whatever are their masses. Okay, in the absence of a resistance they will fall with the constant acceleration. So how did he convince the people? This is an experiment that was first done. It is said by Galileo, who dropped two balls from the top of the Leaning Tower of Pisa. They were seen to fall side by side and hit the ground at the same time. If you put a metal plate on the ground, then the experiment is even more convincing, for you hear a bang, not a bang bang, because both the balls will hit the ground at the same time. It means one bang will be heard, not two bang bang. If the timings at which they hit the grounds are different, of course, one could hear bang bang. But what was heard? One bang. Okay, in the absence of air resistance, both heavy and lighter ball they hit the ground at the same time, and only one bang is heard. So here, this experimental view is shown. Two balls are being dropped. In fact, all objects falling near the Earth's surface have the same acceleration, provided they are not significantly affected by air resistance. So this is a condition. Air resistance affects the motion of the bodies. Okay, it means this will oppose that gravitational force, and acceleration due to gravity will not remain the same. Sometimes, like a feather, a leaf, or a sheet of paper would not have such a big acceleration for it would be significantly affected by the air resistance, because lighter object air resistance will be acting more on them, so they will fall slowly in the presence of air resistance. However, if the metal ball is allowed to fall side by side with a feather in a tube from which the air is removed, it means the tube is evacuated. Then they would fall side by side and they will hit the ground at the same time. On the moon, there is no atmosphere, so no vacuum tube is necessary. When astronauts went to the moon, one of the experiments they did was to drop a hammer and feather together. They fell side by side and hit the lunar surface at the same time because there was no air resistance to affect the motion of the falling objects. Here, two bodies, ball and feather, are being fallen together. The acceleration of objects acted on by gravity only means no air resistance is called the acceleration due to gravity or the acceleration of free fall or the gravitational field strength, and it's represented by g. At the surface of the earth, g is equal to about 9.8 meter per second square, and we rounded it off and we call it 10 meter per second square to make the calculation easy. And you remember what does that g equals to 9.81 meter per second square or 10 meter per second square means? Speed of an object which falls freely under the gravity increases by 10 meter per second every second, and speed of the object which is thrown against the gravity decreases by 10 meter per second every second. So Galileo claimed people already knew this without realizing it. Okay, he thought people knew it. Okay, but they didn't realize it. Now imagine driving a nail into the board by dropping a weight on it from various heights. Everyone already knows that the further it falls, the more impact, which it must mean it's moving faster. It means from the greater height, it will produce more impact. If suppose an object is dropped from a height of 5 meter and the other object is dropped from a height of 10 meter. So of course the one which is dropped from the height of 10 meter will have greater impact, and on hitting the ground its final velocity will be greater than the one which was dropped from the height of 5 meter, because the final speed will be greater here, so it will produce more impact. A feather falls slowly, but Galileo argued that that motion, fairly steady speed, was dominated by air resistance. So was unlike ordinary falling of a weighty object. Of course, weighty objects they experience less air resistance because they are denser than air. Okay, so he found another way to slow the things down. Here is his experiment in two parts: the pendulum and the ramp. Okay, so the pendulum also it vibrates, and it this vibration is due to the gravity. In the same way, an object falling through the ramp means an inclined plane. What will happen to that object? It will gain. Suppose this is the ramp. Okay, when it falls, the object falls. This one. Okay, its vertical height changes. Which vertical height is to be considered? This vertical height. This one. Okay, so if the ramp is of greater altitude, if you have more slopy ramp like this, So this ramp will cause, and you drop it from the same height. Drop the object from the same height means this way. Same vertical height it is. You can notice this vertical height and these two vertical heights are same here. Okay, but the length of the ramp, if you drop it from here, this object is dropped from here. Of course, since this ramp is more inclined, so the object will gain more speed at the bottom compared to the object dropped in this. So free fall motion is the motion of an object acted on by gravity alone. Air resistance does not affect it. Okay, it's not significant. But what about an object that was being thrown straight up and is at the top of its motion and thus stationary for a moment? Is it in free fall? Yes. Even if if an object stops at a height, it will be in the free fall state. Okay, so G will be acting even if the body is at rest or the body is anywhere in the path, like during the journey. Suppose this is your ground. Okay, and at this position, or when it stops at the maximum height, at all the position, value of G will be 9.8. Okay, everywhere it will be 9.8. It doesn't mean that when the object stops at a height, it will not have G any like at all. It will have this G. Okay, and at every position, G will be, this will be 9.8, and it will at 9.8, or you can say 10 meter per second square at all the positions. Okay, what is the difference for the bodies which fall downwards? Like suppose we have a ball which falls downwards. So what happens? What is the difference? It will speed up. While falling downwards, it will speed up. While going upwards, it will slow down. Okay, so speed increases, but because it falls in the direction of the gravitational force, so it will accelerate, and we say this is a positive acceleration because direction of motion and G both are in the same direction. In this case, ball slows down. Why it slows down? Because G acts vertically downwards. G and velocity are in the opposite direction. So for the case when the ball is moving upwards, it slows down and we take G negative because it is opposite to the direction of motion of the ball. For bodies moving upwards. For bodies moving downwards, since the velocity is also downward, we take G positive. Okay, and at anywhere during the journey, at the maximum height, at rest it is, or at the ground, when it is at rest, G will always be that 10 meter per second square or 9.81 meter per second square. What an object that has been thrown up vertically, such as a piece of chalk, suppose I throw upwards just after it has left my hand. Even an object that has been thrown up and is still rising fits the free fall definition. So the equation of free fall can be caused. Just be careful to use positive and negative signs to indicate the direction properly. Okay, just I told for the upward direction, you take G negative because the direction is opposite to the direction of motion. G downwards and motion is upwards. Okay, and for the downward motion, you take G positive. Here, there is a diagram showing all this. Here, object is thrown upwards, so velocity is constantly decreasing, and at the maximum height, velocity has become 0. But G at all the position is 10. Here, the object starts falling. So what happens when it starts falling? Its V velocity increases. Okay, and it hits the ground with the maximum velocity. Okay, so velocity increases by 10 meter per second every second, and here velocity decreases by 10 meter per second every second. Okay, the value of g varies slightly between different places on the Earth's surface. It is a little higher at the poles and little lower at the equator. What is the reason? Because of the spinning of the Earth. Spinning of the Earth causes the shape of the Earth to be a slightly squashed away. Okay, it is bulging out at the equator and it is flattened at the pole. So it's flattened at the pole means poles are nearer to the center of the Earth, whereas equator is slightly away from the center of the Earth. So value of g depends on the distance from the center of the Earth. So value of g is slightly less at the equator compared to the value of g at the poles. Okay, this is Mars. Okay, and g value of g on this Mars is 23.19 meter per second square. Okay, and on Moon it is 1.6 meter per second square. Moon has no like very small gravity, because gravity also depends upon the mass of that object. Okay, so Moon is 6 times lighter than this Earth, so its gravity is also smaller than the Earth. Okay, we using G, we can calculate the weight of an object. We know that W is equal to mg. Okay, so W is measured in Newton, weight is a force, and mass is measured in kilogram. Okay, so don't make mistake in writing weight in kilogram. Okay, weight is a force, so it is measured in Newton, and mass is slightly different because mass is amount of matter, but the gravitational force depends on the mass. For the heavier mass, the gravitational force will be greater. Like for 1 kilogram mass, gravitational force is 10 Newton. For 2 kilogram mass, the gravitational force will be 20 Newton. Okay, so W is equal to mg. If you apply, value of g will be same in all that case when you talk about Earth. For the Moon, value of g for every calculation will come out to be 1.6. Okay, so this equation, 1 kilogram object weighs 10 Newton on the surface of the Earth, or you can say an 100 gram object will weigh 1 Newton. Okay, so how I had to write the mass as 100 gram and not as 100 gram otherwise? It may confuse G. Okay, so you, because G is the symbol for the gravity as well. Now, what happens? You drop a rock from a cliff. Of course, it falls downwards. When a skydiver jumps from a plane, he or she will fall to the ground. To a skydiver's speed, what happens to his speed as he is falling? He will reach terminal velocity due to air resistance. Now we will talk about the effect of air on the motion of the object which will fall towards the earth. Okay, because motion, presence of air does affect the speed with which the objects fall towards the earth. Okay, so they will their acceleration gradually will decrease and they will start falling with the constant velocity, and we call it terminal velocity. Okay, so what are the forces on the skydiver when he falls, and how do these forces change? We will talk about these forces. What happens if the skydiver changes their position, and skydivers force, the vertical force is weight in the beginning, and the other force is air resistance. Okay, so that will affect the speed of the skydiver. If there is no air resistance, there will be only one force, that is air resistance acting on the skydiver. If there is only one force, no air resistance, means there will be only weight acting downwards, no upward force. So he will have a constant acceleration of g equals to 10 meter per second square. But in the absence of this was in the absence of air. In the presence of air, g will not be, we will won't call it g. Acceleration of the skydiver will keep on decreasing. In the beginning, when there is zero air resistance, g will be 9.81 or 10 meter per second square. But when air resistance comes into action, it will act upward, and the downward force will remain equal to the weight, and the resultant force will be what? Downward force minus upward force. It means resultant force will keep on changing. Okay, so the falling objects are subject to the force of gravity, pulling them down. Okay, that is the weight, mass into gravity. On the earth, the strength of the gravity will take 10 newton per kilogram. We are taking it as a force here. And on the moon, it is 1.6 newton per kilogram. Here is a diagram showing the free fall. You have to complete the stages, label the force, and you have to draw correctly the size of the force in this, when and where which force is greater. Okay, where he has just dropped at this position, and here he is falling, and air resistance has come into action. Here he has opened this parachute, and the parachute is opened properly. So what will be the effect? Let us see stage 1. Just after jumping from the plane, the skydiver is not moving very fast. Their weight is bigger force than the air. He is moving actually due to his weight. Okay, so he will accelerate due to his weight, and the acceleration will be in the downward direction, and there is no air resistance. Okay, just after jumping. Now this is air resistance starts acting. Okay, this is weight, and the air resistance in the upward direction, weight in the direction downward direction. Resultant force will be the difference of the two forces. Stage 2, eventually the force of the air resistance has increased so much that it is the same as the size of the skydiver's weight. Both are equal. Both are equal because air resistance will keep on increasing with the increase in the velocity. Till the weight is greater than the air resistance, skydiver will keep on gaining speed in the downward direction. Velocity will increase, but the rate at which velocity increases will decrease. Acceleration will not be 10, but still it will be gaining speed. But due to the increase in the speed, air resistance will also increase, and eventually it will become equal to weight. So at this stage, what has happened? Both forces are equal. Upward force is equal to downward force, so no resultant force. So at this stage, skydiver achieves the terminal velocity, constant velocity, because you know that when resultant force is zero, body at rest will remain at rest, and body moving will continue moving with the uniform velocity. Now here, since the parachute is open, so air resistance will become greater than the weight. So what will happen to the paratrooper? He will slow down. Why? Because upward force is greater than the weight. Now weight will remain constant. Whatever is the weight of the skydiver, that will remain the same. So it will not change. So air resistance is larger. So it means resultant force now acts in the upward direction. In the previous, this one, resultant force is zero. In this one, resultant force is in the downward direction. Okay. Here, resultant force zero, terminal velocity, and here the speed decreases. When speed decreases, means the air resistance will also start decreasing, because air resistance is it depends on the speed. Okay, so with the increasing speed, air resistance also increases. Stage 4. As the diver slows down, the resistance force from the chute is reduced until it is the same. Again, it will become equal to weight. Okay, now again with the parachute also, it will achieve lower value of terminal velocity. In that previous case, it was higher value of terminal velocity, and here the velocity decreases, he decelerates. Okay, because resultant force acts in the upward direction. It means acceleration is also in the upward direction. Here, because the air resistance was increased in the previous window, it was increased, so velocity was decreased, so air resistance starts decreasing again and becomes equal to the weight of the diver, and again he achieves new value of terminal velocity which is lower than that first one. Okay, this value of terminal velocity is less than the previous one. Okay, so this happens with the parachutist. When the vehicles and falling objects first move, they have much more force accelerating them than the resistance which is trying to slow them. Okay, as the speed increases, resistance builds up. Resistance also increases in the opposite direction to the direction of motion, and bodies they achieve terminal velocity. This is the graph showing the terminal velocity. Here, when the parachutist has just jumped out, okay, at t equals to 0. So in the beginning, air resistance is 0. So he has this free fall acceleration. Okay, but air resistance comes into action, and his speed increases, but at lower rate. Here, there is still more speed than the previous one, but the rate at which speed increases has decreased. Air resistance now eventually become equals to weight, and at this position the constant terminal velocity is achieved. This is the higher value of terminal velocity. At this point the parachutist opens the parachute. Now air resistance has become greater. Upward force is greater than the downward force at this point, so object slows down. Okay, rapid deceleration is there. Okay, and but due to the decrease in the speed, air resistance starts decreasing, and again it becomes equal to the weight of the diver. Here at this point the air resistance was greater than the weight of the diver, but at this point it has become equal to the diver's weight, and he achieves the terminal velocity. Okay, lower value of terminal velocity, and this is higher value of terminal velocity. Let us see, this is the label diagram here. Everything is labeled here. This is lower value of terminal velocity, and this is the higher value of terminal velocity. Here there is what? First rapid decrease in the speed, and then slow decrease in the speed because air resistance starts decreasing due to the decrease in the speed in this region. Okay, and here air resistance has become equal to weight, and the parachutist hits the ground with that lower value of terminal velocity. Now there are few questions. So here you have to like masses, skydiver is shown. What is the equation which links weight and gravitational field strength and mass? You have to answer the question. What causes the force X? And as the skydiver falls, the size of force X increases. What happens to the force Y? Whether it decreases, increases, or remains the same. You have to answer this question. Describe the motion of the skydiver when force X is smaller than the force Y, and when the force X is greater equal to the force Y. And I'm adding here one more, when the force X is greater than the force Y. Okay, now this is the fluid sand. Their surface area, speed of the object, they fall through any fluid, means any liquid or gas. A drag force acts. Drag force, that is again liquid resistance or air resistance, which acts in the opposite direction to that of the motion. Okay, so here the resultant force will be the difference of the two forces, weight and the upward drag force. If the two forces are equal, terminal velocity will be achieved. So that terminal velocity that depends upon the surface area of the body as well as density of that fluid. Okay, so accelerating force acting on the falling object is gravity, and all objects would fall at the same rate when there is no air resistance, and the drag is due to the area and the shape of the object, which determines the terminal velocity. When terminal velocity will be achieved, that depends upon the surface area, and if surface area is big, terminal velocity will be achieved earlier, like when the parachute is opened. Okay, person slows down more quickly. Okay, and if the surface area is small, terminal velocity will take longer to be achieved. Okay, when with the parachutes open, the same force, W equals to mg will be downwards, it won't change, but upward force will change, it will be greater. Here answers are there for those questions which were asked. So you can see these answers. And this is about the resultant force for the objects moving horizontally. Okay, so here in most resistance acts in the bodies which move horizontally also, like moving car horizontally also experiences a resistance. So if the driving force decreases, object will decrease due to a resistance and the friction. Okay, so that will tell the presence of resistance will tell whether what will happen to the motion of the body. For example, this is the mass. Okay, this is a question actually. Mass is given, and driving force is this much, and the drag force is given here, and the speed of the car is 70 kilometer per hour. What is the acceleration when this comes to rest? Initial speed is this, so you have to calculate the acceleration. uh, okay, so that's all for today. So we will have another video related to it, inshallah. Till then, Allah Hafiz. And please watch the video again if you have not understood any point, and let me know and ask the questions related to the topics which are taught.